Okay, so we've got a question here that talks about a tangent to a circle. So under the what do we know, then we can add on the radius line, because the h help ourselves by adding lines on. So that's got a gradient, we'll call it m1. The tangent line meets the radius at 90 degrees, so they're perpendicular to each other. So we'll call the gradient of this line m2. And the rule for perpendicular lines when they meet is m1 times m2 equals -1. So the product of the two gradients must always give you an answer of -1 if the two lines meet at a right angle or perpendicular to each other. So if we work out the gradient of the radius, then m1 will equal y2 take y1, the change in the y coordinates, divided by the change in the x coordinates for 2 points on the line. Well, the 2 points we'll choose are those two. So we end up doing 3 take away 0 over 4 take away 0, so 3/4. So m1 is equal to 3/4. Using the rule of perpendicular gradients, then we can see that 3/4 times m2 will equal -1. So m2 will equal -1 divided by 3/4, which equals -4/3. So we know that the gradient of the tangent line is now -4/3. Well, once we know that, then because the question wants the equation of the tangent line, all straight lines have the general format y equals mx+c. I've called it m2 because we're talking about the tangent line here. So we now know that y must equal -4/3 of x plus the intercept point. Now there's lots of ways of working out the intercept point. If it was on graph paper, we could just go off and read it. We could use the idea of the gradient to go back 3 up 4 and so forth and work it through that way. But we're going to use a coordinate because we know the coordinate on the tangent line is 4, 3. So at the point 4, 3, we know that x is worth 4 and y is worth 3. So our equation will become 3 equals -4/3 times 4 plus c. Rearrange this, then c must be 3 plus 16/3, which is equal to 25/3. Okay, 3 whole ones is 9/3 plus 16 1/3 makes 25/3. So that gives us our final answer for this question then of y equals -4/3 x plus 25/3. So that's how that question could be done, recognising that the tangent meets the radius at 90 degrees, therefore they're perpendicular to each other, and the rule for perpendicular lines is the product of the two gradients is -1. Work out the gradient of the radius, you then know the gradient of the tangent line, put that into the general format for all straight lines, y equals mx+c. Find the c value by using a coordinate on the tangent line, by substituting the values for x and y, and then put it together, you've got your equation.